numericals on equation of continuity. Right there. Friends, or should I? A cylindrical tube was it's based on equation of continuity. A cylindrical tube of spare pump has a cross section of 8 centimeters square on one end, of which has 40 fine holes, each of diameter 1 millimeter. If the liquid flow inside the tube is 1.5 meters per minute, what is the speed of ejection of the liquid through the holes? What is this? So a cylindrical tube of a spare pump has a cross section of 8 centimeters square. So what we can do is that, okay, fine. So this is A1. A1 is 8 centimeters square. One end of which has 40 fine holes of each of diameter 1 millimeter. So in the other end, you have so many perforations. Is that so? Here, V1 is 1.5 meters per minute. Read the question. A cylindrical tube of a spare pump has a cross section of 8 centimeters square on one end. Okay. One end of which has 40 fine holes. Of diameter 1 millimeter. So what is the speed of the liquid coming out of it? What is V2? Now, are you able to understand this? Okay, do this, boys. 11B.
Ma'am, should we know the formula that we derived for Bernoulli's theorem? Should we
No, this is not Bernoulli. So this is not
this
Bernoulli.
Like that formula, should we remember? The one that we derived for Bernoulli's theorem?
Okay, I have completed that, right?
Ma'am, you've completed that. Like, should we know that formula to solve numericals?
Yes, boys, you should know.
Okay,
you should know those formulas. Boys, have a rough diagram of this and then start doing A1 V1 is equal to A2 V2. Do you understand this? You have a cylindrical tube. One end of the cylindrical tube is having an area of cross section 8 centimeters squared. The other end is having 40 fine perforations. Each has a diameter 1 millimeter. Right? So what will be A2? How will you find A2? A2 will be area of 40 times the area of one hole. Yes or no? Was A2 will be equal to 40 times area of one fine hole. Okay. So A2 becomes equal to 40 into pi r square, right? Pi r square. Now what is r over here? 1 by 2. Millimeter should be converted to meter. Okay, boys. D is 1 millimeter. So R will be equal to 1 by 2 millimeter, or R becomes equal to 1 by 2 10 to the power of minus 3 meters. Boys, is that correct? You need not calculate A2. The question is, what is V2? The question is, what is V2? So you can substitute. If you keep calculating, you are wasting your time. They're asking you to find V2. A1 is given as 8 centimeters squared. What do you have to do? Convert it to meters. So 8 into 10 to the power of minus 4 meters square. Was centimeters squared should be converted to meters squared. So A1 becomes equal to 8 into 10 to the power of minus 4 meters squared. Correct? Now calculate. Calculate V2. So you have to be careful. What is V1? V1 is 1.5 meters per minute. So how should you convert V1? Should I do that or will you be able to do, boys? V1 is equal to 1.5 meters per minute. So you have to convert it to seconds. So V1 is 1.5 by 60 meters per second. Was Is that clear? The entire board looks clumsy. Should I erase and write it properly? 11B. 11B.
Ma'am, this is fine.
It's fine. Boys, what you wait, I'll go for her. What is happening? Boys, I'm A1, I'm converting it to meters square. A2 is, you have to calculate A2, 40 pi r squared. R is, V1 is, just see the highlighted part, because you are converting millimeter to meter, minutes to seconds, centimeter to meter square.
Ma'am?
Yes.
Ma'am, so we should substitute R in A2, right?
Correct.
Okay, ma'am.
And then you have to find what is V2.
Okay, ma'am.
Ma'am, is it 38.1 meter per minute?
38.1.
1.
Okay, fine.
38.18. Yeah, that.
Just check boys. It is, I think somewhere half is 1 second. Is that correct? 38 means, I think you have to multiply somewhere with 2.
It's a small mistake. Sorry.
Was textbook numerical. Are you all getting 0.64 meter per second?
Ma'am, 0.636, is that fine?
Okay, it's fine. Boys. 2 decimal places, fine. Boys,
Ma'am?
others? Yes,
Ma'am, for the pi value, I have used 3.14.
1,
Is it
4.
fine?
Okay, it's fine. It's fine.
Okay, ma'am.
Well, now we'll go for Bernoulli's theorem, numerical. Boys, shall I move for the next numerical? 11B.
Yes, ma'am.
Okay, fine. Right, boys. In a test experiment on a model aeroplane in a wind tunnel, the flow speeds of the upper and the lower surfaces of the wing are 70 meter per second and 63 meter per second respectively. What is the lift on the wing if its area is 2.5 meters square? Will you do this, boys? In a test experiment on a model aeroplane in a wind tunnel, the flow speed on the upper and the lower surface.
Ma'am, is this a textbook question?
Yeah, yes, I think so. Boys, 1 second. Suppose this is your model aeroplane, on a test model aeroplane in a wind tunnel. The flow speeds on the upper surface of the wing and the lower surface. So here what is the speed? V1 is 70 meters per second. Correct, boys? What is V2? 63 meters per second. What is your
Ma'am, is it
Bernoulli's
a
theorem?
textbook question?
Yes, boys. What is Bernoulli's theorem over here? P1 plus half, okay, rho V1 squared plus half, sorry, plus rho G plus rho G H1 must be equal to P2 plus half rho V2 squared plus rho G H2. This is your Bernoulli's theorem, right? Clear, boys? Now, only one assumption you have to make is that the wing, right? This suppose this is your, say, let us take this as your ground. The thickness is so small that the upper and the lower edges are at the same height. H1 was, this is, say, if I take this as H1, this let me take it as H2. The thickness of the wing, right? The thickness is less, so I can write H1 is approximately equal to H2. Can I do that? If I'm doing this, then what happens to these two terms?
And they cancel.
They will cancel. So, because they will cancel off, right? Then what is left? What is left? P1 plus half rho V1 squared is equal to P2 plus half rho V2 squared. Are you clear, boys, why the last two terms got cancelled? If you see the thickness of the wing is negligible, it's very thin, so that the height of the curved part as well as the height of the lower surface of the wings almost at the same height from the ground. Is that clear, boys? So H1 and H2, we are approximately removing it off. Now, look at the question. What is a lift on the wing? Lift on the wing means what? Lift on the wing means what? Is that force or is it what else? When you're lifting the wing, there should be a net force. There is a force, boys. What is a lift on the wing? What does it ask? What is it? It means
Upward.
Okay, upward force. Only when you have an upward force, you will have a lift on the wing. So what is that you have to calculate? What is that you have to calculate? Force. If you have to calculate force, what should you find? How force, pressure and area are related? How pressure, force and area are related? Pressure is equal to force upon area. So force is equal to pressure into area. Yes or no, boys? See, the question is, what is the lift on the wing? The net force acting on the wing in the upward direction. So they're asking for force. Here, what is the general expression for force? Force is pressure into area. Here, your top surface will have a pressure, say P1. Lower surface is having a pressure. This difference in pressure is giving you the force. Should I explain that phenomenon once again, boys? That the wing, because there is a difference in pressure. On top layer, the velocity is high, so pressure is less. On the lower surface,
Ma'am,
velocity
can
is
you
low,
explain
pressure is high.
that?
Okay.
Like your voice was breaking a lot in the first video.
You were not able to understand anything.
Not ma'am, not anything, but the theorem I
Most
couldn't
of it.
understand.
Theorem.
Yes,
Okay,
ma'am.
fine.
This theorem.
Fine, boys. Now look at this. You consider this aerofoil as your wing of the airplane, right? This one is the wing of your airplane. Fine. Now, as the aeroplane moves, you know stream of airs are going to streamline of air is moving on top surface of the wing as well as the bottom surface of the wing. Your top surface is curved, which means the air has to travel a longer path compared to the air which is flowing below the lower surface. Are you clear, boys? The wind is blowing, which means the air molecules are in motion. So the movement of your air on the upper surface, because upper surface is curved, which means it has to travel a longer path compared to the lower one. Lower one is almost a plane surface. So when it is traveling a longer distance, right, your speed should be high. When you're traveling a longer distance, see the lower layer of air is traveling a shorter distance. Right? Both the layers of air should reach this point. If it has to reach this point, the lower one is traveling a lesser path, so that it has to travel with a lesser speed. Upper one is traveling a longer path, so it has to travel with a greater velocity, so that all the air molecules can reach this point at the same time. Still, you're not understanding. Was this is how your airflow, it's a laminar flow. Your airflow is a laminar flow, right? Air is flowing in this way. You keep an aerofoil. What happens the moment you keep your aerofoil? The air will move like this. Upper surface it will get curved, lower surface it's fine. So if the air molecule has to reach this point A, this one here, the air has to travel with a greater speed because it's traveling a longer distance because of the curved path. This is your wing. The upper part, the layer of air which is traveling on the upper surface of your wing has to travel a longer distance, whereas the layer of air which is traveling the lower surface, near the lower surface of the wing has to travel a lesser path, but both should reach the point A at the same time, which means the air molecules which are traveling above the surface of the wing should be faster. When you're traveling a longer path, you should move fast. The other person is traveling a shorter path. Right? If you want to reach the same destination, when you're taking a longer path, you have to walk fast. The other person taking a shorter path can walk slow so that both of you will reach the same point. So what they are saying, on the top surface, your velocity of air is higher, the pressure will be lower. Here, the lower surface, the velocity of the air is lesser, pressure will be higher. So lower surface of the airplane wing will be maintained at high pressure, upper surface will be maintained at low pressure. So then what happens? Air will always try to move from a region of high pressure to low pressure. That is why you have an upward thrust. See, the movement will be always from higher pressure to lower pressure. There is a difference in pressure. The top surface is at low pressure, the bottom surface is at high pressure. This high pressure will make it to move up. This is what is airlift. Is that clear, boys? 11th standard? 11th?
Yes, ma'am.
Now, go for this. Now here in this case, we'll have to apply Bernoulli's theorem. Boys, please listen. So this is an aerofoil. So I'll take here the speed as V1, pressure as P1. Here, this is an aeroplane. The wings of your airplane. Now this is velocity V2. Here the pressure is P2. Clear, boys? So your Bernoulli's theorem, what is your Bernoulli's theorem? P1 plus half rho V1 squared plus rho G H1 is equal to P2, because you are applying Bernoulli's theorem on top surface as well as on the bottom surface. P2 plus half rho V2 squared plus rho G H2. Now what assumption you are making is that your airplane is flying at a very great height, boys. What is the maximum altitude you are traveling? What is the maximum altitude you are traveling, boys? You're traveling in your aeroplane, right? They always announce this is the altitude. The plane is flying. Okay, just take it as 36,000 kilometers above the ground surface, right? Now look at the difference between, suppose the top surface is at a height H1, the lower surface is at a height H2. This distance H2 minus H1 is very minimal. If you compare the total distance, right? If you compare your wing, the height of the wing with respect to the ground, the thickness of the wing is very less, which means H2 is approximately equal to H1. That is what you are considering. Clear, boys? Clear? So these two will get cancelled. Are you clear? Right. Now what is left, boys? P1 plus half rho V1 squared is equal to P2 plus half rho V2 squared. So now P1 minus P2 will be equal to half rho V2 squared minus V1 squared. Okay, what is P1 minus P2? Difference in pressure. That I'll put it as delta P. Okay. And what is force? What is force? Okay, you calculate till, okay, you calculate this, boys. The change in pressure. You calculate this value. This is change in pressure. Don't substitute the values. Just write change in pressure. Have a rough diagram and do it, boys. This is your Bernoulli's theorem. Mathematical form of Bernoulli's. This is your mathematical formula of your Bernoulli's theorem. B. Jacob is in your class. Aaron. Jonathan. Jatin.
Yes,
Jatin is
ma'am.
not here. Okay. Maheshwar. Danish. Rishit. 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 Shamshul. What's the problem with your Shamshoy? Have we copied? Okay. Now, how will you calculate the lift? Lift means the force. How will you calculate, boys? Shall I erase this? Boys, shall I erase?
Sure, ma'am.
Now you just tell me how will I calculate? Okay. So what is force? Force is equal to change in pressure into area. Because the change in pressure is only giving you the uplift into area. Okay. So that is your uplift. So now calculate this. So uplift will be equal to, what was delta P? What was half? No, what was the formula for delta P? Surya? Dheeraj? Dheeraj? What is the formula for the uplift? Dheeraj? Austin?
Is it 1 by 2 P
No,
V2 square
okay.
minus
What is
V1 square?
the formula you got for change in pressure? What's the formula did you get, boys?
1 by 2 P V2 square minus V1 square.
Okay, that is rho density, boys. V2 squared minus V1 squared into area. What is the density of air given as? 1.3. What is V2 squared? So I can go for 70 squared minus 63 squared, but anyway, it's negative. Okay, 70 squared, I'm just taking it as minus 63 squared into what is the area? 2.5. Now what's the value, boys? Calculate. Okay, correct. Abhishek, Abhishek's microphone is not working. Abhishek, calculate the uplift, boys. What's the value you're getting? Derek, I think so. I have to take this response for your PT3. Boys, I'll include these marks for your upcoming PT3 if you're not answering. Derek. Are you getting this? Just check, boys. Are you getting this? Fine. I'll go for one more numerical, or should I go for the theory? Once I think for tomorrow we'll go for 2 periods are there. One period I'll go for numerical, first half I'll go for theory. 1 second. What are these balls? Boys, next class, if you're not answering whether it's right or wrong, that doesn't matter. If you people are not answering in class, I will take it up for your PT3. Right? This response will be added for your PT3.
Ma'am.
Even if it is wrong, even if your work is wrong, nobody is going to, right, either shout at you or don't hesitate. If you don't understand, you just tell us that you need one more revision. Speak up, boys. We don't know whether you are doing your work or not. Even if your working goes wrong, not a problem. Yes.
Ma'am, I don't know about the rest. Ma'am, I don't know about the rest, but Abhishek, like I just messaged him asking what's wrong, and he said his screen is just stuck in like the reconnecting screen. So it's like can't hear you.
Fine. If that is the case, boys, you send a message to the other friends. But often I'm just checking. Some of you are not answering at all. Jatin, Rishit. Rishit, are you there in class? Boys, take things seriously.
He is. He usually responds.
He usually?
I think he's logged. Yeah, he's logged in with using another device, so I don't think the mic works in that device.
Okay, fine.
He usually responds. I know that.
Okay, fine. Thank you. You can leave.
Thank you, ma'am.